Hello dear students, a very good morning everyone. Welcome to the session and welcome once again to your favorite live learning platform, that is the BYJU'S exam prep. Alright. Very good morning everyone. Good morning Ashok. Come on, so let everybody join quickly. Alright. Hi, good morning Shiv. So let's get rolling ahead then. Just a second. Good morning Rakesh, good morning Ritik, good morning Hussain, very good morning all. Chalo. So a lovely wonderful morning to all. It's Sunday and it's like the beginning of World Cup for our nation today. I mean, officially World Cup started on 5th of October, but today is like the beginning of World Cup for us because today is the first match of India, okay, with the Australia. Very good morning Ananta, good morning Bhanu, good morning Gate Easy. Okay. As a true GATE aspirant, do not spend the complete time on the match. It was just a discussion. Okay, but as a true GATE aspirant with 4 months left in hand, do not spend the full time on match. If you don't like it, no problem. If you really like it also, just be updated about the score. Okay, maybe just follow an app like Cricinfo or something, just be updated about score. But if you are watching it continuously, it is not appreciable. Okay, at this point of time. Okay, because something... Okay, of course everybody should cheer for the nation. Okay, you can wish for them, but you watch or you don't watch is not going to change the fate of the match. So better you focus on your preparation as well. Okay, be honest with your preparation because that is going to matter most for you. That's what my advice is. Okay, thoda bahut half an hour if you see, that is okay, but don't give the entire day to it. Chalte. Okay, chalte. 21 important questions on differential calculus. Okay, 21 important questions on differential calculus. Actually, these 21 questions will also sum up the differential calculus. Okay, good morning Harihar. Okay, we'll sum up almost many formulas of the differential calculus. So let's get started guys quickly. This is a regular introduction about me that you can go through later. So guys, for the today's PDF class, like all other my classes, you will get the PDF along with the detailed discussions and solutions of the question in my Telegram group. And other than that, for important daily doses, for other doubt discussions, for updates about my classes, for updates about the upcoming GATE exam, PSU, etc., you can just be connected in my Telegram group. I will share you the link of Telegram in the chat box also. Okay, and also guys, today Sunday, yes, 8th of October, the national scholarship test, okay, from BYJU'S exam prep, okay, already started. Okay, so this is live up to 9 PM. You can appear on the BYJU'S exam prep app and get as much as 90% scholarship on the GATE preparation programs and take a next step towards your success in the GATE examination. Okay, also guys, at the same time, a very important special workshop Wednesday, okay, that is 11th October at 7:30 PM. Abhinav Negi sir brings to you, okay, the free live interactive workshop to discuss about the possibility to cover the GATE 2024 syllabus. How much can you cover? What is the perfect time to cover? And can you cover everything timely? Okay. Okay. So join Abhinav sir, okay, on Wednesday 7:30 PM. Chalo, here it is the first question for you now. Okay, permutation you want to say, Ashok? Thank you, Ananta. Chalo guys, starting with the fundamental, factual question, you can say that let's get started with the warm-up question. Oh. Just a second, I have to check the settings by the time. Okay, Hanji, chaliye, tell me. So what is the answer for this? What is the answer for this? At the same time, let me also mention that this is MSQ. At the same time, let me also mention that it is a MSQ question. Okay, consider the following statement about the function, select the correct option, your options. Okay, if you feel more than one option correct, that is also possibility. Multiple select question. If a function is continuous, then it is also differentiable. Is it sure? No. Continuity is just a condition of differentiability, right? If a function is continuous, then it may not be differentiable, right? Correct, right? So why you are only saying C? What is the problem with B? B is also correct. It may not be differentiable. True, it may be, it may not be. It is continuous, that is the first condition of differentiability, but it may or may not be differentiable. Correct? So B is absolutely correct. If a function is differentiable, then it is also continuous 100%. 100%. Because without continuity, differentiability hota hi nahi hai. So if it is differentiable, sure it would be continuous. Okay, if it is differentiable, then it may not be continuous, not possible, because if it was not continuous, then we cannot say it is differentiable. So correct answer is B and C. Okay, B and C. No, not D, Rakesh. Okay, so B and C both will be there, Jashwant and Manu. So just check it out. Multiple select question. Be careful in reading the options. It is option number B and C, both correct. Okay, I think maybe the language may not be confused you. If I say if a function is continuous at x0, it may be differentiable, tab kya bologe? Then you will say yes, na? So if it is maybe differentiable, okay, it may not be differentiable also. Both the options are there, na? Okay. Chalo, theek hai, done hai. So this was just a warm-up question. Okay, now let's get started. Okay, and in solving a numeric based on this, numeric based on these calculations. So there is a function given to you, e power x. It is split into two parts. E power x for x less than 1. Okay, ln x plus ax square plus bx for x greater than equal to 1, where x belongs to the set of real number. Which of the following statement is true? It's a MCQ question only. Okay, now the question is asking about the function being differentiable or not differentiable. But before differentiability, what you should check? Before differentiability, something that you have to check is continuity. Okay, then only differentiability arises. Okay, so if it is differentiable, it has to be continuous. Now, what is the final condition for continuity? Okay, that's what. So with this question, you will also revise the final condition for continuity. Okay, which says that the left hand limit should be equal to right hand limit, should be equal to the value of the function at the point A. Should be equal to the value of the function at the point A. Suppose you are checking the continuity at x equal to 1. Okay, left hand limit. How do you designate left hand limit? Acha, at the same time we will solve some limit questions also today. Okay, direct limit questions also, because although they are simple but they are important, very frequently limit questions are coming up. Okay, the left hand limit, limit x tending to a minus of fx is equal to right hand limit x tending to a plus of fx is equal to the value of the function at the point A. Is equal to the value of the function at the point A, correct? Okay, if this is true, then the function is said to be continuous at the point x equal to a. Acha ji. Now, okay, how to solve it up? Do you have to solve it limit way? No, it's going to be actually very simple. Dekhna yahan pe. Okay, now where should you check? Of course, options say at x equal to 1. And why do you have to check at x equal to 1? Because x equal to 1 is the point where the definition of the function changes. Okay, so whether it is maintaining the continuity in the value, whether it is having a sharp point or not, everything has to be checked at x equal to 1. Okay, so let us now check. Let us now check what? Let us now check the continuity at x equal to 1. So what is the left hand limit? Left hand limit, as I told you, limit x tending to 1 minus fx. Now how to substitute this value? Okay, 1 minus. Now what is the meaning of 1 minus? Okay, when x is tending to 1, okay, but slightly lesser than 1, it is approaching 1, tending to 1. Okay, limit tending to 1. So x is approaching 1, but from the values which is less than 1. Okay, left side se aa raha hai. Okay, left side se aa raha hai. So when the x is slightly less than 1, what should be the function? E power x, na? What should be the function? E power x. So substitute the function limit x tending to 1 minus of the fx, and fx is equal to the e ki power x. Is equal to what? Is equal to the e ki power x. Okay? Okay, now x tending to 1 minus. Now put down the x tending to 1. Okay, now ultimately put down the x tending to 1. Okay, so e power 1. So left hand limit is e power 1. Okay, acha. Okay, right hand limit. Right hand limit. Then right hand limit is known as the limit x tending to 1 plus fx. Okay, that is limit of x tending to 1 plus of fx. Now 1 plus means x is approaching 1 from greater side, from right side, from x greater than 1. And if the x is greater than 1, what is the definition for function? Ln x, write down this. Okay, ln x plus ax square plus bx, correct? Correct, perfect. Now put down x equal to 1 actually. Put down the x equal to 1, and here if you put x equal to 1, log 1 is 0, okay, plus a plus b, okay, x ka value 1 hai, so it is simply a plus b. Log 1 to 0 hi hai, so it is simply known as the a plus b. Okay, now for the function to be continuous, okay, let's match the first two parts na. Let's match the first two parts. Okay, क्योंकि f1 का value तो same होगा, f1 when x is greater than or even equal to 1, okay, so f1 is also a plus b, f1 is also a plus b. So when you equate left hand limit equal to right hand limit, you are getting e is equal to a plus b. That is one condition. Let's say this is one equation, okay, because the question, again I repeat, because the question is talking about differentiability, so it is 100% compulsory to also clear that continuity, otherwise the function cannot be differentiable. Okay, so if it has to be continuous, okay, if a plus b equal to e, okay, now let's check the differentiability. So what is the derivative? How to check the differentiability? How to check the differentiability? Okay, a quick review. So how you are going to check the differentiability? For the differentiability, okay, basically check, okay, number one, the function should be continuous, otherwise don't talk about differentiability. जब function ही define नहीं होगा तो differentiate नहीं कर सकते at that point. Okay, next, check the left hand derivative equal to the right hand derivative. Okay, left hand derivative equal to the right hand derivative. Okay, what is left hand derivative? Okay, that is given by, see, what is the basic meaning of derivative? F of x plus h minus f of x divided by h. Okay, change in the function upon change in x. That is what is the basic meaning of the derivative. That is what is the basic meaning of derivative. First principle of differentiation. So when I say left hand derivative, we take limit of h tending to 0 minus right hand derivative, limit h tending to 0 plus, okay, f of x plus h minus f of x divided by the h. Okay, that is the second condition. That is the second condition. Okay, and third condition. Okay, the third condition is that the derivative of the function at that particular point should also be defined. Okay, that is f dash. Okay, f dash at the point a, suppose you are checking at a, okay, differentiability at the point x equal to a, at the point x equal to a, so f dash a should be finite, f dash a should be finite. Okay, now please pay attention. Okay, this point can be simplified actually. This point, you don't have to solve f of x plus h minus f of x upon hy. Okay, because this is the first principle from which the differentiation formula, all the formulas come up. But do you know the differentiation formula, na? You already know what is e power x differentiation, what is x square differentiation, what is x cube differentiation. Since you already know, you don't have to apply the first principle. Okay, what you can do is, okay, the left hand derivative, okay, at the left hand derivative, okay, should be equal to right hand derivative. That means dy by dx, okay, dy by dx x tending to a minus should be equal to dy by dx at x tending to a plus. At x equal to a left hand and right hand derivative, just like you are checking the limit. Okay, just like you are checking the limit. Okay, correct, Rakesh, that's what I'm telling. So just like you are checking the limit, na, left hand limit, right hand limit, check the, it's like checking the limit of differentiability. Left hand derivative equal to right hand derivative. You should not use first principle because you already know the differentiation formula. So चलिए आ जाते हैं function पे अब. So what is the derivative of the function then? What should be the derivative of the function? So the derivative of the function, dear, okay, e power x, differentiation e power x, then log x 1 by x, ax square 2x, x square का differentiation 2a plus bx, तो x का differentiation 1. This is for x greater than equal to 1. The first one was for x less than 1. This is the derivative. This is the derivative. Now what is the value of left hand derivative? What is the value of left hand derivative? The left hand derivative means the value of the derivative, okay, the value of the derivative at x tending to 1 minus, now x tending to 1 minus, as I told you, 1 minus means you are approaching 1 but from the value which is less than 1. So if x less than 1, what is the derivative? E power x. Okay, in the e power x, you will put down x equal to 1, directly substitute, this is equal to e. Okay, what should be the right hand derivative? What should be the right hand derivative? Right hand derivative is x dash f dash x for x tending to 1 plus. For what? For the x tending to 1 plus. Okay, now 1 plus means you are approaching x from x greater than 1 side. Okay, when x greater than 1, this is the derivative. So I will use the derivative 1 upon x and I will keep substituting x equal to 1 directly. Na? So x equal to 1 upon 1 plus 2a into 1, okay, plus b. So this is 2a plus b plus 1. Okay, now what you need is, okay, e is equal to 2a plus b plus 1. This is your second equation. For the differentiability, we need these two equal, na? Okay, so you had 1 and 2 equations here. You have the 1 and 2 equations here. So now, okay, so, just a second, what is the problem happening? So if you take back the two equations, a plus b equal to e, and next was 2a plus b plus 1 equal to e, correct? Na? Yeah, okay, this was the first, this was the second. Okay, you can directly subtract. Okay, if you subtract 2 minus 1, okay, you will be left with a minus 1. Okay, you will be left with a, b cancel hua, okay, a plus 1, and that is equal to 0, so a is equal to minus 1. Okay, and if a is minus 1, so first equation वापस लिया, तो minus 1 plus b equal to the e, b will be equal to the e plus 1. So what you are ultimately getting is, there are two unknowns a and b and there are two equations. So if you have two unknowns and two equations, you will get a unique solution here, that is a minus 1 and b equal to e plus 1. Now options क्या बोल रहा है? fx is not differentiable for any value of a or b. No, I have proved it can be differentiable. Fx is differentiable at x equal to 1 for the unique values of a and b. Yes, unique value means when you have a particular value only, that is a minus 1 and b equal to e plus 1. So the very correct answer is option number B here. The very, very correct answer is option number B. Done it? Chalo, next question then. Next question then. Should be ready for you. Here it is. Yeah. Limit x tending to 2 minus x 10 pi x by 4. Tell me. Correct. B was the correct answer. Any doubt in the previous question, you can let me know. Chalo. Tan of limit x tending to 2 minus x tan of pi x by 4. If you try to analyze this problem, okay, if you put x tending to 0, if you put x tending to 2, this is 2 minus 2 multiplied by tan. Agar x ka value rakha 2, so 2 by 4 will be pi, so tan of pi by 2, which is like 0 multiplied by infinity. Yeah, infinity can be taken as 1 upon 0. Okay, so it's 0 by 0 form actually, and if you have the 0 by 0 form, what you can apply is the L'Hospital. Okay, so if you apply the LH rule, apply कर लेंगे. Okay, अच्छा, but for LH rule you need the numerator and denominator. Okay, उसको differentiate करना पड़ेगा. So I can write this in a way such that it is limit x tending to 2 minus x, and let me write down the tan in the denominator, so it becomes cot pi x by 4, correct? Now it is numerator by denominator form. Okay, now if you convert it to the LH rule, so different answers are coming in the screen. Let's check it out. So now if you apply the LH rule, we differentiate both the numerator and denominator. 2 minus x ka derivative minus 1, minus x ka derivative basically minus 1, cot pi x by 4. What is the differentiation of cot? Minus cosec square pi x by 4, correct? But by the chain rule, pi by 4 will also come. Minus cosec square pi by 4, pi x by 4 into pi by 4. Now if you put the x tending to 2, so it will be minus 1 upon, okay, minus को तो हटा ही देते, minus is cancelled, तो 1 upon cosec square pi by 2. X की जगह 2 रखा, तो you get pi by 2 and whole multiplied by pi by 4. So this is equal to, now sin pi by 2 is 1 and hence cosec pi by 2 is also 1. So you are only left with 1 upon pi by 4. So your answer is 4 upon pi. Your answer is 4 upon pi. It's a numerical answer type question. Let me put down the value. It's 1.27 actually. Approximately, you can fill the answer as 1.27. ठीक है जी? You can fill the answer as 1.27. Check it out, check it out, check it out. Huh? Pi by 4? 1 upon pi by 4, na? 1 upon pi by 4. So that will become 4 by pi eventually. Ashok. Okay, so check out the answers again, Rakesh and Ananta. Okay, it should be the 4 by pi, that is 1.27. Okay, it's pi by 4. Nahi, pi by 2 only, na? X will be 2. Okay, x will be 2. Okay, Ashok. X ka value 2 rakhoge, so it becomes pi by 2. Okay, x of 2 pi by 4, that's what is pi by 2, na? Otherwise, so this also will not be this. If you take x equal to 1, okay, then the answer is 2 minus 1 into tan pi by 4, answer will be 1. But x tending to 1 nahi bola na, x tending to 2 bola, then it is not 0 by 0 case. Okay, so check it out, check it out, check it out. Next question. Number 4. Limit x tending to infinity, square root of x square plus x plus 1 minus of x. So what form this function is taking? What form it is taking? X is tending to infinity. Of course, the infinity plus infinity and under root bhi leke it is infinity. Okay, then minus x, that is minus infinity. So this is infinity minus infinity form. Dear, is infinity minus infinity 0? Infinity minus infinity is not 0. It is an indeterminate form. There are two infinities. Okay, infinity is used for any value which is extremely large, which you practically can't calculate. Okay, but this infinity may be slightly bigger or lesser also than the other infinity. So it may or may not be 0. Okay, never take infinity minus infinity laga equal a minus a cancel 0. No, it is not 0. First of all, I am telling you, don't say that the answer is 0. Okay, please don't put up and say that the answer is 0. No, Venkat, answer is not 0. Maybe. But if you are looking directly infinity minus infinity as saying that 0, then it is not correct. Then it is not correct. Okay. So next, okay, regular L hospital direct applications many are able to solve. Isko kaise karenge? So what you have to do is x tending to infinity is troubling you. X tending to infinity is that point of trouble. What I will do is I will make a substitution here. Put down x equal to 1 by t. Okay, so that t it will be tending to 0 because x is tending to infinity. The reciprocal will be tending to the 0. Okay, reciprocal will be tending to the 0. Okay, and now accordingly this problem will become, rather than x, I am solving in terms of t. Limit of what? T tending to 0. Root over of x square, that is 1 by t square, plus x, that is 1 by t, minus 1. Okay, minus x, that is minus 1 by t. Okay, do solve it up now. Okay, okay. Chalo. So now when you try to solve it up, okay, you can take this also t square LCM. Okay, this is limit t tending to 0. So t square का अगर LCM लिया तो 1, then t square by t minus t square whole minus 1 and whole divided by t. Okay, whole divided by t. Actually, let me write this here once again. This is limit t tending to 0, 1 plus t minus t square whole minus t whole minus 1 actually divided by t. Divided by t. Okay, now put down the t tending to 0, dear. Okay, so you are going to get root 1, then minus 1 upon 0, 1 minus 1, 0 by 0. Now you get 0 by 0, and if you have 0 by 0, then only you can apply L hospital. L hospital either 0 by 0 or infinity by infinity. Okay, infinity by infinity. That also you can take Ananta. Okay. अब आ जाते हैं यहाँ पे. So limit of t tending, it's a 0 by 0 form. So now I am straight away applying the LH rule, and if I apply the LH rule, differentiation of suppose root x, okay, is 1 by 2 root x. Is 1 by 2 root x, and then differentiate. Okay, 1 ka differentiation 0, t ka differentiation 1. Okay, and 2t ka differentiation, t square ka differentiation 2t. Okay, then differentiation of 1 is 0. Whole divided by differentiation of t with respect to t is 1. Okay, this is what is the result after LH rule, and now again I will be putting the same limit of t tending to 0. So now if you try to put the limit 1 by 2 root 1, okay, 1 minus 0 whole divided by 1. So the answer is simply ye ho gaya 1 by 2, rest everything is 1. So the answer is 1 by 2. Correct hai ji? It is not 0, hence proved. It is not 0. Correct Bhanu, correct Ashok. Okay, it is equal to 1 by 2. Option number C. ठीक है जी. So sometimes, you know, limits questions can also confuse you and get you into wrong zone. So be careful about this. Okay, now this is a different variety of question from limit. If limit x tending to 0 sine 2x plus a sine x upon x cube equal to b, where b is a finite value, then find the value of a and b. Then try to find the value of what? Try to find the value of a and b. Tell me. Try to find the value of a and b. A equal to minus 2, b equal to minus 1, etc. Okay, so now this limit after solving is equal to b, and b will be finite. Then what should be the value of a and b? What should be the value of a and b? Okay, so it's a slightly different variety. Solving it, some limit is given, and some within the limit some unknowns are given. So देखो, if you directly put x tending to 0, you have sine 0, okay, plus again a sine 0, divided by 0 cube. Sine 0 we all know is 0, so eventually it is 0 by 0 form. Eventually it is the 0 by 0 form. Clear है जी? It is the 0 by 0 form eventually. अच्छा जी, ठीक है. आगे देखते हैं. So 0 by 0 है तो let's go for L hospital. Okay, let's go for the L hospital. So let me apply the LH rule here. Okay, so after I apply the LH rule, I am going to get limit x tending to 0. Differentiation of sine 2x is 2 cos 2x. 2 cos 2x. Okay, plus a sine x. Okay, sine x differentiation cos x divided by x cube differentiation is 3x square. But now put x tending to 0. So cos 0 is equal to 1. Cos 0 equal to 1, but denominator is 0. Okay, cos 0 equal to 1. Okay, so you have only 2 plus a, okay, divided by 0, 2 plus a by 0. Now dear, if by chance numerator is non-zero, okay, देखो ध्यान देना, the conditions are if 2 plus a does not equal to 0, then 2 plus a upon 0 will become infinity, na? If it is non-zero upon 0, okay, any finite upon 0 number will become infinity. 1 upon 0 case, that is infinity. Okay, but this is equal to b, so wrong, because b is finite. Okay, because b should be finite. Okay, right. So you have to take, so you are left with no choice. You have to take 2 plus a. You have to take the 2 plus a equal to 0, and this gives you the value for a, that is equal to the minus 2. a का value minus 2 आ गया, ठीक है? a का value minus 2 आ गया, done है? Okay, done है. So a is obtained. Okay, now if a is obtained, then 2 plus a upon 0 is now 0 by 0 form. So once again LH will apply. Once again LH will apply, so apply LH. Differentiation of cos 2x minus 2 sin 2x. Okay, so I will now have limit x tending to 0 minus 2 to the 4 sin 2x. Okay, a cos x differentiation minus sin x. So minus a sin x is divided by 3 to the, that is the 6x. Okay, and then if x is tending to 0, dear, if x is tending to 0, this becomes 0, this becomes 0. Okay, so ultimately it is again 0 by 0, because sin 0 0 hai na, so it is 0 by 0. And now if it is 0 by, this time automatically 0 by 0, so I will go to the next step, that is once more LH. Okay, once again LH. Come on LHG, let me help to solve the problem again. So now this is becoming limit of x tending to 0. Okay, minus 4 to the 8. Okay, so minus 8 cos 2x minus a sin x differentiation, simply cos x, divided by what? Divided by 6x ka differentiation, that is 6. Now put down x tending to 0. At 0 cos 0 is 1. Okay, cos 0 is 1, so you have minus 8 divided by 6. This time it is definitely a non-zero form. Okay, and this should be equal to minus 8 minus of a is already obtained. Okay, so कितना हो गया ये? minus 6 by 6 minus 1, and this is the value of b. The final limit is equal to b, na? Final limit is equal to b, na? So b का value आ गया 1. The value of b obtained is 1. Okay. Okay. B equal to 1. Yeah, at this step you can apply that also, Vamshi, correct. At coming to this particular step, initially it was cubic, but if you want to come to this particular step, you can solve by that as well. Okay. ठीक है, you can solve by sin x by x, but just try to rearrange Vamshi. If it is sin 2x, here also you should arrange 2x, and here sin x upon x. Okay, that you can take, because sin theta by theta will be 1 for theta tending to 0. So sin x by x, and this should be sin 2x upon 2x. Accordingly rearrange, that is also okay. ठीक है जी, correct है Vamshi. So done है, तो b also obtained -1. b is -1, not +1, -1. Okay, and a is equal to -2. A is -2, b is -1. My answer is option number A. What do you say? Correct. Yeah, Ananta. Yeah, Shabir. Correct. ठीक है, option number A is my choice. Done है? Done. Next question then. Okay, number 6 ready for you. Okay, let f of x plus y is fx xy for all xy, where f0 not equal to 0, f5 equal to 2, f dash 0 equal to 3, then what is f dash 5? Okay, slightly conceptual question. It is a slightly conceptual question. You know what is the hint to solve it up? थोड़ा सा hint देता हूँ, then you please try it out. थोड़ा सा मैं hint देता हूँ. Okay, what is the hint to solve it up? Any idea? Okay, you want f dash 5. What should be f dash 5? Okay, because the function is not specified. If the function was clearly given, I can differentiate and find its value. But function is not given, so I will go by the first principle rule to solve it up, and I will apply some concepts of limit then. First principle say f dash 5. So what is f dash x? Is f of x plus h. तो यहाँ पे क्या लिखेंगे? f of 5 plus h minus f of x, that is f of 5 divided by the value of h, and for small change in h, that is limit h tending to 0. We will apply the first principle to solve it up. This is the hint. Now please deal and let me know what is the answer you're getting. I shall just bring up my charger by the moment. Okay, now hope so you have got something. The hint was properly given to you. Now let's move ahead here. Okay, now f dash 5. Okay, now how to solve f of 5 plus h? That is what? Now f of x plus h is fx f5 for all values of x and y. Okay, so if I use that condition, I will be having limit h tending to 0. F of 5 plus h is f of 5 into f of h minus the f of 5 is divided by the value of h. Okay, out of which f of 5 का value तो given है मुझे, so now it becomes simple. Okay, it becomes simple, little bit simple, अभी भी पूरा नहीं हुआ है. Limit of h tending to 0, f of 5 is equal to 2. Use this value. F of 5 is equal to 2. So 2fh minus 2 divided by h. Okay, now put h tending to 0. So something else is given. F0 is not equal to 0. is not equal to 0. But what is f0? Okay, अब यहाँ पे requirement होगा 2 को common भी ले लें, so this will become f0 minus 1 whole divided by 0. What is f0 now? What should be the f0? How to calculate f0? That is not given. f0 is not equal to 0, but what it is equal to, that is not given. So what you can do is, okay, it's a good question actually. Okay, here this is applicable for all values of x and y. Okay, put down x equal to y equal to 0. So if x equal to y equal to 0, okay, so 0 plus 0 will be 0. So f0 will be equal to, this is also f0, this is also f0. So f0 is equal to f0 ka whole square. Okay, it's like x equal to x square, and if you solve x equal to x square, you will get two roots. f0 equal to 0 or 1. 1 square is 1, 0 square is 0. Okay, you will get the two roots. But f0 cannot be 0. Okay, ये बोला है ना, f0 cannot be 0. So f0 का value 1 है. So the value of the f0 equal to the 1. f0 value 1 है. Zero by zero form it is. It is a 0 by 0 form. ठीक है? ठीक है. Now let's move ahead. Because it is 0 by 0, so it's a good question of concept of function mixed with the limits. Now 0 by 0 है, so I will solve by the LH. Okay, let's apply the LH here on this particular form. So I have limit of h tending to 0. 2fh, differentiation will become 2f dash h divided by h ka derivative 1. Okay, so now you only need to put h tending to 0. So you have 2f dash 0, and for your sake f dash 0 is given to you. F dash 0, that is equal to 3. This is a known value. Okay, so 2 multiplied by 3, your final answer is 6. It's a good question. It's a good question. Correct answer Bhanu, correct answer Sagnika. The correct answer is 6. Very good guys. The correct answer is equal to the 6. Okay, is equal to the 6. Okay, let's move ahead to the next question. Okay, that is number 7 here. Okay, find C. Okay, find C of the Lagrange's mean value theorem. Okay, for fx equal to log x in 1 to e. Lagrange's mean value theorem. Okay, Lagrange's mean value theorem in the interval 1 comma 3. Okay, which simply says that, consider a function fx in the closed interval a comma b. ठीक है, if f of x, number 1, you just need to check two conditions. Just be sure about two conditions. A function if fx is continuous, okay, is continuous in the interval 1 comma e. Okay, it is differentiable in the open interval 1 comma e. Okay, if the function is continuous in the interval 1 comma e, differentiable in the open interval 1 comma b, then what is the result of Lagrange's mean value theorem? Okay, then there will be a point. Okay, ये जो c बोला है ना, then there is a point x equal to c. Okay, which belongs to the interval a comma b. That means there will be some value between the value of a and b such that the derivative of the function, at the point c, okay, such that the derivative of the function at the point c is given by fb minus fa is divided by b minus a. fb minus fa divided by b minus a. It has a very simple proof, but right now we are not looking into proofs. We are looking into questions and the logics behind them. Okay, that's what is necessary for this revision part right now. The fb minus fa is divided by the b minus a. This is what the answer should be. fb minus fa divided by the b minus a. F dash c is equal to fb minus fa upon b minus a. Now, okay, now let's pay attention. Now, acha, let me complete one more thing. Okay, suppose, okay, so this is the LMVT result. Okay, this is the LMVT. Okay, let me add third condition. Okay, let me add third condition. One more condition. If fb equal to fa, then we will come to the question. If fb equal to fa, okay, then third condition, if you also add, then there is a point x equal to c belonging in the interval a comma b such that what will happen? F dash c will become 0. If fb equal to fa, okay, then the f dash c is directly 0, na? Okay, that is what, this is the Rolle's theorem result. Okay, Rolle's theorem. The previous one was Lagrange's mean value theorem, that we simply call it as LMVT. Okay. If FB also equal to FA, that is the Rolle's theorem. Okay, we'll come to the Rolle's as well. Now pay attention. Okay, find the C of the LMVT for the function fx equal to log x. So now let's come to the question. What is the fx? Okay, what is the fx equal to log x? Okay, guys, some important conditions na, chalo wo bhi revise kar dete hain. Okay, some important conditions must always be known to you. Okay, what are the important conditions? Okay, any polynomial function. Okay, then the sin x and cos x, sinusoids function, then e power x. Polynomial functions means x, x square, x cube, etc. Any function in the form of x, x square, x cube, etc. You know, all these cases, okay, are always continuous and differentiable, okay, for minus infinity less than x less than infinity. That means for all values of x, okay, you must know these results, they are helpful. Okay, the basic function, sin x, cos x, exponential function, polynomial function, they are always continuous and differentiable. Okay, then what about log x? What about the log x? Okay, log x, that is also, okay, that is also always continuous and differentiable, okay, but for x greater than 0. Okay, that is 0 less than x less than infinity. Okay, for x greater than 0. The log x is continuous and differentiable. Anyways, for negative number, log is not defined, and log 0 is minus infinity. So log 0 is also not defined. It is not continuous. So the log x is continuous and differentiable for all positive values of x. Okay, positive values of x. Okay, now the function that is given to you, you have to apply the LMVT for the function fx equal to log x in the interval 1 comma e. In the interval 1 comma e. Now if you look into this interval, x is greater than 0. The interval is 1 comma e, positive range is given. Okay, so I can say that fx is number 1 continuous. I told you, for any positive value of x, log x is continuous and differentiable both. So it is continuous in the given interval. Okay, it is also differentiable in the open. Actually, it is differentiable in the closed interval also, but let me write according to LMVT. Okay, so f dash c. Acha, what will be f dash c? What will be the f dash c? What is f dash x actually? Log x ka differentiation 1 by x. Okay, I'll put x equal to c. So what is f dash c? 1 by c. According to LMVT, what should happen? F dash x, okay, should be equal to fb minus fa. Okay, fb, that is fe, the second point is e, minus fa, that is f1, divided by b minus a. This should be the result. This should be the result here. Okay, now what is fe? Fx is log x, so that is log e. Okay, minus log 1 divided by e minus 1. Log e, log and e will inverse, they'll cancel. Log 1, always 0 for any base. Log 1 is 0. So 1 minus 0 upon e minus 1, that is 1 by c. So what should be the value of c? Okay, c will be e minus 1. 1 upon c is 1 upon e minus 1. So c is equal to e minus 1. That is the answer for the question. C is equal to the e minus 1. So you can expect the straight questions on the Lagrange's mean value theorem. ठीक है जी? You can expect the straight questions on the Lagrange's mean value theorem. On the Lagrange's mean value theorem. ठीक है? Chalo, done है. Let's come to the next question then. Okay. Any doubts you can keep asking me. Answer was B. Let's come to the next question, number 8. Forget. Let's go to the 9th. Let's complete LMVT related. Then I will come back to the previous question. Okay. Let's go to this one. Okay, suppose that f R2R, that is the domain real number, range is also complete real number, is a continuous function on the interval minus 3 comma 3 and a differentiable function in the open interval minus 3 comma 3. So whose conditions are given? Okay, whose conditions are given? Dekho, it is continuous in the closed interval minus 3 comma 3 and it is differentiable in the open interval minus 3 comma 3 such that for every x in the interval, okay, for every x in the interval, f dash x is less than equal to 2. Okay, if f minus 3 equal to 7, f3 is at most equal to what? 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 Okay. Now there, okay, for every x in the interval f dash x, acha, what should be f dash x according to LMVT? According to LMVT, what should be the f dash x? Because the function is continuous and differentiable in the interval, okay, if I apply the LMVT in the interval minus 1 comma 1, okay, I should be telling that, okay, f dash x should be equal to what? Should be equal to fb, okay, sorry, minus 1 se 1 nahi, minus 3 se 3, it should be the minus 3 se 3. So f dash x is equal to f3 minus f minus 3 divided by 3 minus minus 3. ठीक है. Now pay attention. What is the value of, some values are given, f minus 3, that is 7. तो इसको put कर देंगे. So f3 minus of 7 divided by 3 minus minus 3, that is known as 6. That is known as the 6. Okay. So f3 is at most what? So now you are given a condition. ये at most कहाँ से आएगा? You are given that f dash x is less than equal to 2. Correct. But what is f dash x? According to the LMVT theorem, f dash x is given by f3 minus 7 divided by 6. Okay. f3 minus 7 divided by 6, this is less than equal to 2. I have just put the value of f dash x according to the LMVT. Correct answer Sagnika and Ananta. Okay. So now solving it, this is 6 2s are 12 and 7 on the other side, that will become 19. So I am getting that f3 is less than equal to 19. Less than equal to 19. f3 is less than equal to 19. Okay, the maximum value is 19, na? 19 or less than 19. Okay, so what is the maximum value? Is 19. The f3 is at most means maximum value, no? So its maximum possible value will be 19. ठीक है जी. Its maximum possible value will be 19. Okay, correct answer Ashok. Hanji, correct Suresh. Done. So it's 19. So now this was like our application. The question number 7 was direct LMVT. This is like an application of LMVT. Indirectly you have to think. Question number 7 में एकदम direct बोल दिया था कि वो find the value of C of LMVT. Okay. Now question number 8. Okay. One of the roots of the equation. Now this is like an equation question, sir. Why this question is coming up here? Okay. This is actually an application of Rolle's theorem. You will feel. Okay. One of the roots of the equation lie in the interval. See, whenever you read a statement like this, okay, one of the roots of the equation, okay, lie in some interval. Okay, which interval you have to find? Think about Rolle's. Think about Rolle's. Okay. Now, whenever such a question arises, okay, whenever such a question arises, let that function be f dash x. Let that, equation, that function on the left side be f dash x. That is known as sin x plus x cos x. That can be written as sin x plus x cos x. Okay, इसको ऐसा लिख लेंगे, sin x plus x cos x. That should be what? That should be the f dash x. Now, if this is f dash x, what will be fx? What will be fx? So, to calculate fx, we will integrate the above function, or you can manipulate whatever it is. You can manipulate this. So, see, sin x, okay, आप इसको ऐसा भी लिख सकते हो. Okay. You can write the f dash x as, okay, f dash x as, देखो, cos x and sin x are derivative of each other. So cos x का derivative sin x. Okay, here x का derivative 1 I can say. Okay, here x का derivative 1. So what I can feel is कि I can write this as d by dx of x. जो 1 है ना, 1 can be written as d by dx of x into sin x. Okay, plus x, and as I am telling you, cos x is the differentiation of sin x. Now can you think what is this? Okay, when you are differentiating x, sin x is constant. When you are differentiating sin x, x is constant. It is the product rule of differentiation. Okay, so I am telling you it is easy by manipulation. Otherwise, you can integrate directly. Okay, so this is like differentiation of the product rule, like x sin x. It is the d by dx of the x sin x. So what is the value of fx? Okay, what is the value of fx? Okay, so fx is equal to x sin x. fx equal to x sin x. ठीक है? ठीक है? Now dear, listen to the very important point. Okay, listen to the very important point. Okay. Now consider the fx in some interval a comma b. Okay, and if fx is number 1, if fx is number 1 continuous in the interval a comma b, number 2 differentiable in the open interval a comma b. Okay, and number three, fa equal to fb. Okay, fa equal to fb. Then what I told you, I'm repeating the Rolle's result. Then what I told you, then there is a value. Okay, then for some value of x belonging to the interval a comma b, f dash x, Rolle's theorem result, f dash x equal to 0. Rolle's theorem result की बात कर रहा हूँ, not LMVT. So f dash x equal to 0. Dear, what is f dash x? The sin x plus x cos x. Okay, that means sin x plus x cos x equal to 0 in the interval a comma b. Okay, somewhere in the interval a comma b. F dash means sin x plus x cos x. So it will be somewhere in the interval a comma b. Now what is a comma b? A comma b should be the interval where the Rolle's condition are satisfied. Okay, what is the fx? Okay, what is the fx? Fx is x into sin x. X means polynomial part, sin. Okay, it is x into sin x. X is polynomial and sin x anyway sinusoidal. I told you that polynomial function and sin x cos x, they are always continuous and differentiable for all values of x minus infinity to infinity. So this is like always continuous and differentiable for all values of x. So iska tension nahi lena hai. That means first two conditions are met. First two conditions are met. So since it is always continuous and differentiable, so I can say that it is continuous in the interval a comma b. It is continuous in the interval a comma b. Number two, it is differentiable in the open interval a comma b. And number three, what you have to meet it, fa equal to fb. Fa equal to fb. So you have to find an interval such that fa equal to fb, because any interval you select, continuity and differentiability is ensured. But if you find an interval where fa equal to fb, then you know what you will do, then Rolle's theorem will be satisfied, and according to Rolle's theorem, f dash x will be 0. That means sin x plus x cos x equal to 0. That is your equation. So your root will be obtained. In what interval? A comma b, such that fa equal to fb. So now let's try with the option. Okay, now let's try with the option. Option number A. What is the option number A? Minus pi by 2 comma 0. Minus pi by 2 comma 0. So what is the value of fa? What is the value of f minus pi by 2? Okay, that is equal to minus pi by 2 into sin minus pi by 2 minus 1. So this is pi by 2. What is the value of f0? That is 0. Not equal. Not equal. Okay, so option number B पे जाएंगे straight away. We have to do it by option matching only. Option number B, 0 comma pi. 0 comma pi. So f0 directly 0. F pi, dear, f pi is also pi into sin pi. Sin pi 0 है ना? Okay, so here you get fa equal to fb. Okay, and when fa equal to fb, then you will get the root of sin x plus x cos x. So in what interval are you getting the root? In the option number B, that is 0 comma pi. Okay, and it's a MCQ question. Okay, so once you get an option correct, it is a MCQ question only right now. So once you get an option correct, you can stop, need not check others. Option number B is the correct one. Option number B is the correct one. Okay. Okay, it's a good question. Application of Rolle's theorem. This is on the application of Rolle's theorem. Okay, so mean value theorems. Okay, also we have covered along with the continuity differentiability, the mean value theorem, LMVT and Rolle especially. Let's move ahead to the next one. The 9th was done. That was the application of Lagrange's mean value theorem. Okay, here we have 10th. Let's also take up Taylor's, not that important, but let's cover up the Taylor's as well. So in the Taylor series expansion of the function fx, okay, equal to log of sec x about the point x equal to 0, what is the coefficient of x power 4? So dear, in general, what is the expansion of fx about the point x equal to a? Okay, provided that function fx is differentiable. Okay, and if I am telling it is differentiable, then automatically I am expecting it should be continuous also. Okay, the expansion of fx about the point x equal to a is written as f of x is given by the formula f of a, okay, plus x minus a f dash a, okay, plus x minus a squared, so divide by 2 factorial into f double dash a, okay, plus x minus a, so if you take the cube, next term divided by then 3 factorial and then f triple dash, third derivative, and etc. This goes up to the infinity. Okay, this goes up to the infinity. That is what is the Taylor's expansion actually. That is what is the Taylor's expansion. Okay, so in this Taylor's expansion, what is the general term? What is any general term? What is any general term? So suppose if you take the term x minus a power n, okay, so it should be divided by factorial n, and then you should have the nth derivative. Okay, so general term can also be discussed with you, or like the coefficient. Okay, coefficient. So if I ask you, if I want to write down coefficient of, if I want to write down coefficient of x equal to a, if I want to write down coefficient of x equal to a, if I want to write down the coefficient of the term x minus a power n, coefficient means the factor which is multiplied along with it. Okay, so what is multiplied with x power, x minus a power n? It is fna divided by factorial n. Okay, divided by factorial n. Remember this coefficient formula also. Okay, coefficient formula also. Okay, so fna upon factorial n. Okay, fn means the nth derivative. It is not f power n, it is fna. Okay, it is nth derivative. F power n nahi hai. Okay, acha, if you take the expansion about origin, then if you take the expansion about origin, about x equal to 0, that specific series is also named as the Maclaurin's. That particular series is also known as the Maclaurin's series. And what is then? What is that written as? F of x is like f of 0, okay, plus x f dash 0 plus x square by factorial to f double dash 0 plus x cube by factorial 3 f triple dash 0 and etc. 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 Just the special case when you put x equal to 0, okay, that becomes the Maclaurin's case. Okay, that becomes the Maclaurin's case. Okay, so now here if you want to write down the coefficient of, here if you want to write down the coefficient of x power n, क्या हो जाएगा? X power n का coefficient, it is going to be the nth derivative at the point 0 divided by, okay, divided by factorial n, divided by the factorial n, okay, divided by factorial n. ठीक है? Okay, that is the coefficient of x power n. अब देखना, I need the coefficient of x power 4 in the fx equal to x log x. ठीक है, यही करते हैं. Okay, fx equal to x log x. Okay, so what is the f dash x, dear? Let's keep differentiating. Log ka derivative 1 upon x. So log of sec x differentiation 1 upon sec x. Then by the chain rule you differentiate, you get sec x tan x. You get sec x tan x. Sec x into tan x. Sec theta differentiation, sec theta tan theta. Sec and sec got cancelled. Answer is the tan x. Answer is the tan x. That is the f dash x. Okay, but because I want the coefficient of x power 4, so I need to go up to the fourth derivative, na? Very clear. So what is the f double dash x? What is the f double dash x? Tan x ka differentiation, sec square x. What is f triple dash x? What is f triple dash x? Now sec square x derivative, 2 sec x, number 1. सबसे पहले तो x square 2x, तो sec square x 2 sec x. Then by the chain rule, sec theta differentiation, again sec theta tan theta. Okay, so this becomes actually 2 sec square x into tan x. This is up to the third derivative. I need to go up to the fourth derivative. That is what is the meaning of f4a. That is what is f4x. A बाद में रखेंगे. So now differentiate this. So you will have to apply the product rule. Okay, 2 को outside रखते हैं. Sec square x का differentiation. Sec square x का differentiation. Already, what is the differentiation of sec square x? That is 2 sec square x tan x. Okay, but if this is the differentiation of sec square x, tan x is constant, okay, plus sec square x constant into differentiation of tan x, that is sec square x. Okay, so what is the fourth derivative, dear? What is the fourth derivative? It is 2 into 2 sec square x tan square x, okay, plus sec square sec power 4x. Okay, now what you want? Coefficient of x power 4. Okay, what you want? Coefficient of x power 4. Okay, coefficient of x power 4, as I told you, it should be equal to f4a. You are expanding about 0. Okay, about 0. So f4 0 divided by factorial 4. What is f4 0? Now put down the value of f4 0. Okay, that is going to be 2 into 2 sec square tan square. Tan 0 is 0. So pehla term 0 plus sec 0 is 1. Sec 0 is 1 upon cos 0. That is why it is 1. Okay, so next term is 1. Whole divided by factorial 4, which you must know is 24. So my answer is 1 upon 12. So my answer is what? 1 upon 12. 1 by 12. Option number A it is. Option number A it is. Correct, Sagnika. Correct, Ananta. Correct answer 1 by 12. That is the option number A. So I'm telling you again, Taylor series not very much important, but yes, you must be aware about the fundamental formula. Okay, what the Taylor expansion is, what is the coefficient of a term, what is the general term in the Taylor expansion. Okay, ye pata hona chahiye. Okay, that is what it is. Next question, dear. Ready for you? Okay, next question. Let's go to the next. Yeah. So before I go to the next, okay, let me also, keep reminding you that if you want more practice, okay, either practice sessions or practice quizzes, anything, you can watch practice sessions, you can directly attempt practice quizzes, okay, the timer based practice quizzes, and compete with your fellow GATE aspirants. Okay, enhance your practice, know about your mistakes, and keep participating in the leaderboard. Do more and more practice. So, and other than practice, some study notes, some important formulas, many things you can get in the BYJU'S app. So you can involve BYJU'S exam prep app in your GATE preparation as a daily routine to, enhance some of your concepts and do more practice. Okay, so you can download this BYJU'S exam prep if you don't have from the Google Play Store, or if there is a link in the description of the video, you can directly download using the link for your convenience. The link is already there in the video, in the description of the video. Okay. So now next question, number 11. Coming to some of the very important areas. Okay, come up to some very important areas. No, Praveen, sorry, it's English and I don't know by the way Telugu, but anyways, it's an English session, comfortable for all. Okay, so if fx is equal to a log x plus bx square minus x has its extreme values at x equal to -1 and x equal to 2, then what should be the value of a and b? Come on. What should be the value for a and b? Okay, extreme values pe aa gaye. Now, what is extreme? Dear, what is this extreme? Extreme covers both. Okay, this is also extreme value. It went to the extreme top. This is also extreme bottom, maxima or minima. So when I just say extreme, you can consider both maxima and minima. So it has extreme values at -1 and 2, and at extreme values, that is maxima or minima. Okay, whether it is maxima or minima, one thing is sure, that the first derivative must be 0. Then whether it is maxima or minima, we go for the second derivative or other rules that we will revise with the upcoming question. Okay, the first derivative test is there, second derivative test is there. Okay, but right now they are only talking that there is extreme values at -1 and 2. So what should be the a and b? Okay, so what is the f dash x? What is the f dash x for the given function? For the given function, a log x ka differentiation 1 upon x. Okay, plus x square ka differentiation 2x. Minus x ka derivative 1. So a by x plus 2bx minus 1 is the value of f dash x. Okay, is the value of f dash x, and now you should put it equal to 0. Okay, you should put it equal to 0. But at which point? Okay, the extreme values are -1 and 2. Okay, so I can say that f dash at those points should be 0. F dash -1 should be 0. Ek condition ye aa gaya. Okay, so a upon, actually next page pe lete hain. So f dash -1, okay, should be 0. So that gives you a result a upon -1 plus 2bx, that is 2b into -1, and -1 equal to 0. Okay, so you must be getting a result from here, a, and that is 2b. A plus 2b equal to the -1. Okay, next f dash 2 also should be 0. at every extreme value f dash x is 0. So f dash 2 also 0. Okay, that means a upon 2 plus 2bx, 2b into 2 minus 1 equal to the 0. Done? Yeah. So solving this, I should be getting a by 2 plus 4b. This should be equal to the 1. This should be equal to the 1. Okay. So now we have to solve these two equations parallelly. Okay, these two equations parallelly. Okay, यहाँ से अगर इसको a में convert कर दिया, okay, so this can be written as a plus 8b is equal to 2 multiplied by 2. So a plus 8b equal to 2. Suppose this was 1. Suppose this is equation number 2. If you subtract, okay, a and a will get subtract. So equation 2 minus equation 1, 8b minus 2b, 6b is equal to 2 minus minus 1, 3, and hence the value b is equal to half, 3 by 6. So b का value तो आ गया, that is half. What about the a value? What about the a value? Okay, what about the a value? So a will be equal to minus 1 minus 2b, minus 1 minus 2b, and b का value half रखते हुए a will be minus 2. तो a minus 2 and b half. A minus 2 and b half. Option number D. A minus 2 and b half. Please check it out. Correct, Sagnika. Correct answer. Good going. A minus 2 and b equal to half. A is the minus 2, b is the half. That's the correct answer. Okay, ji. Okay, done. Cool. Next question. Let's present the next question for you then. Okay, let us get the next question ready for you. Here it is. Next one, 12th MSQ question. Okay, let f r to r, that is the domain is set of real numbers, the range is also set of real numbers. Okay, be given by fx equal to x minus 1, x minus 2, x minus 5. Okay, define fx equal to integral 0 to x ft dt for x greater than 0. Then which one of the following options is or are correct? Which one of the following options is or are correct? Okay, multiple select question, one or more than one option can be correct. Okay, so now f means, look into this, capital F. Okay, capital F has a local minima, has a local maxima, has two local maxima, one local minima. Yeah, f is increasing. Okay, f is increasing. So what should be the method to solve it up? Okay, anyways, whether you want to comment on maxima, minima, or even increasing, okay, which function? Okay, which function? F, capital F. Whose, whatever function you want to check the maxima, minima, increasing or whatever, you have to differentiate the function. So you have to differentiate the function. You have to differentiate the f function. So by the way, what is the f function? What is the f function? Integral 0 to x ft dt. Okay, so if I want to differentiate f dash x, what is f dash x? D by dx of fx. Leibniz rule can be applied to solve this definite integral. Okay, so differentiation and integral are inverse of each other, they should cancel. I should get the answer f. Since it is a definite integral, I will put down the upper limit fx. Okay, but because of chain rule, I will also substitute I will differentiate the limit d by dx of x minus the lower limit f0, and again by the chain rule I should be solving d by dx of 0, but differentiation of 0 will be 0. So and d by dx of x will be 1. So this is simply equal to fx. The capital F dash x is equal to the small fx, and actually the small fx is given to you, x minus 1, x minus 2, x minus 5. Correct? Okay. Yes, Ananta, this one correct. X minus 1, x minus 2, x minus 5. Okay. Now, as I told you, okay, stationary points, roots, and extreme values. What we learned? At every extreme values, f dash x equal to 0. Acha dear, whenever f dash x equal to 0, okay, they are also known as stationary points. They are also known as stationary points. Okay. So now let's have a quick review of everything here. Let's collect all the points here. So सबसे पहले क्या बोला जा रहा है? Okay, for maxima, minima, or for any extreme value, you have to solve f dash x equal to 0. Okay. F dash x equal to 0, whatever roots you obtain from here, they will be known as what? They will be known as the stationary points. Clear? They will be known as stationary points. Okay, now stationary points are of three types. Okay, stationary points can be a point of local maxima. Okay, can be the point of local minima, and some stationary points may be neither local minima nor local maxima. It is not sure that they will be maxima or minima only. So some stationary points may not be local maxima or local minima. They will be known as POI, point of inflections. Okay, such a point where you neither where there is neither maxima nor minima, where there is a neither maxima nor minima. Okay, okay, ठीक है, neither maxima nor minima. These are the three categories. ठीक है. Now, what is the local maxima? Okay, what is the local maxima? Local maxima will be the point such that first derivative to 0 है, but second derivative, okay, second derivative maxima है ना, should be negative. Okay, local minima, okay, the second derivative should be positive. Okay, should be positive. What is point of inflection? Point of inflection is the case where even the second derivative equal to 0, where even the second derivative equal to 0, okay, neither positive nor negative, but the third derivative is non-zero. Whether positive or negative doesn't matter. So if second derivative is 0, that is neither positive nor negative, but the third derivative is non-zero, then that will be a point of inflection. Clear? Then that will be the point of inflection. ठीक है. अच्छा, ये तो हुआ second derivative test. Okay, you should also know first derivative test. Okay, first derivative test. Suppose f dash x changes sign from positive to negative, then what is that point known as? F dash x. Okay, suppose it changes in sign from negative to positive, okay, and okay, maybe around the stationary point f dash x doesn't change sign. Okay, that will be the point of inflection again, POI. Okay, now if it changes sign from positive to negative, understand the idea here. Look into this, guys. This is what is meant by a point of local maxima. This is what is the point of local minima. Okay, so what is happening at local maxima, local minima? What is happening at local maxima, local minima? When you draw the tangent to the curve, okay, थोड़ा review कर रहे हैं theory को. When you draw the tangent to the curve, that tangent is actually appearing horizontal, means parallel to x-axis. Okay, so if the tangent is parallel to x-axis, the slope should be 0. Okay, slope should be 0. So at this is the particular point where slope means f dash x equal to 0, and also at this point f dash x equal to 0. Clear? So you should be clear ki why the first derivative is equal to 0 at the maxima or minima. Clear? Maxima and minima. Okay. Okay, maxima and minima. Now look into this portion. This is known as the portion where function is increasing, isn't it? Where the function is increasing. Okay, when the function is increasing, its first derivative is positive. This is known as the increasing zone. Okay, and then it reaches the maxima and then it starts decreasing. Okay, whenever the function is decreasing, the first derivative is negative. Okay, then it reaches the minima and then it again starts increasing. Okay, increasing means the f dash x is again positive. So look into this, guys. If the first derivative f dash x, okay, changes from positive to negative, changes sign from positive to negative, okay, so that is the local maxima in between. That is the local maxima. So if it changes sign from positive to negative, then it represents the point of local maxima. Okay, if it changes sign from negative to positive, decreasing to increasing, ye wala zone, okay, it was decreasing, reaches minima, then increasing, so that is a local minima point. Okay, this one is the local minima. This one is the local minima. Okay, so out of the two, acha, I will show you the inflection also. Okay, so this one is actually the local maxima and this one is actually the local minima. At both of them first derivative 0 hoga. This is the local minima. Okay. We'll come to global minima actually. Ananta, your question should be more properly local minimum and global minimum. Us pe aayenge. We'll come to the global minima, global maxima also. Ghosh, actually saddle points are more in reference to two variable function. That also I will cover up. Just wait for it. Okay, just wait for it. What exactly saddle point is? Okay. We discuss this with respect to the two variable function. So I have a question for that also. Just wait for it and we will discuss that. Okay. So aa jate hain is pe. Okay. So this is what is the complete summary you should know. Now how to solve that particular question? Okay. Let's go back to the question. So I have f dash x. Okay. First of all, what are the roots of the f dash x? Okay. The roots of f dash x bole to the roots of f dash x bole to kya? F dash x equal to 0 is known as what? Is known as the stationary points. And what are the stationary points? When you equate it to 0, you will get 1, 2, 5. Very simple, na? Now, rather than applying any first or second derivative test, let's make it simple. Solve by the wavy curve method. Okay, solve by the wavy curve method. Ye lijiye. Let us solve by the wavy curve method. Let us solve by what? Let us solve by the wavy curve method. Okay, in this wavy curve, draw the roots first of all. Okay, this is x and I am drawing the wavy curve for f dash x. Okay, which is used to solve polynomial inequalities, a shortcut for it. Okay, so roots kya hai iske? 1, 2 and 5. Okay, 1, and suppose this is 2, suppose this is the 5. The wavy curve, the wave starts from, the wave will always and always start from the right of largest root. Ye largest hai, it will always start from the right of largest root. Right of largest root. And at every root, at every non-repeated root, it will change in sign. Okay, so if it is plus, okay, when you come to this zone, it will be minus. Again, when you come to this zone, plus. Again, minus. Okay, minus plus, ye ho gaya plus, ye again ho gaya minus. This is what it is. This is the wavy curve. ठीक है जी? This is what the wavy curve is actually. Okay. Now, very clear from the wavy curve. Very clear from the wavy curve ki where is f dash x positive, where is f dash x negative. Wherever is the f dash x positive, that represents what? Zone. Increasing zone. Increasing zone. Wherever the first derivative is negative, this is the wavy curve for f dash x, na? So that represents decreasing zone. Now, wherever, always the analysis should be in the increasing value of x. Okay, dekho. Now, at x equal to 1, the first derivative is changing sign. Only, you know, what is the beauty of this wavy curve? Just one curve will tell you everything. Increasing zone, decreasing zone, local maxima, local minima. देखिए ना यहाँ पे. The first derivative is changing sign from around this stationary point. It is changing sign from negative to positive. Negative to positive, decreasing to increasing. Decreasing to increasing. Okay. It's local minima. Okay, ये वाला भी decreasing zone है. Okay, so this particular point is a point of local minima. Now, here the first derivative changes sign from plus to minus, increasing to decreasing. So, बीच में क्या आएगा? Local maxima. So, this should be a local maxima. Similarly, look at this stationary point. The first derivative changing sign from negative to positive. So, that is negative to positive. That is again local minima. Okay. कभी याद ना आए तो think like this, negative to positive. Negative means decreasing, positive means increasing. So what is in between? Minima. You can remember like that also. Okay, so now this one wavy curve tells everything. So now let's just match the options. It has a local minima at x equal to 1. Correct. Okay, correct. Option number B, it has a local maxima at x equal to 2. At x equal to 2 local maxima, this is also correct. B also correct. It has two local maxima and one local minima in the interval 0, infinity. Two local maxima and one local minima. No, sorry, it is two minima and one maxima actually. It is two minima and one maxima actually. So this is not correct. Okay, this is not correct. Okay, then f is increasing for 1 less than x less than 2 and x greater than 5. F is increasing Okay, for 1 less than x less than 2 and x greater than 5, perfect. Because the first derivative is positive, the function f is increasing. So D is also correct. So this is the MSQ question. Multiple select question. Option number D correct hai. It's a multiple select question with the option number D totally correct. Option number D totally correct. Done hai ji? Okay. See, Ananda, wavy curve may always, first write down the roots and start the wave from the right of largest. Sabse last say, and always with the plus sign it should start, Ananda. And at every root which is non-repeated, change the sign. If it is repeated, kya hoga wo bhi batata hu. But every non-repeated root, matlab the root which is occurring only one type, change the sign. Plus 2 minus, then minus 2 plus, then plus 2 minus. Keep changing the sign at every root. Okay. So this wavy curve tells you everything about increasing nature of the function, decreasing nature, local maxima, local minima. That's why it's very important and very beautiful. Can the wavy curve also tell the point of inflection? Can it also tell the point of inflection? Ye dekhiye. At the point x equal to 0 function fx equal to x cube has what? Why, let me draw the cubic function. You must have seen the quadratic cubic waveforms, isn't it? Why, quadratic or cubic ka waveform kaise dikhai deta hai? I hope you are aware about this, na? The parabolas and the cubic curves and etc. So okay, no problem. If you want to revise it up also, ये देखेंगे हम. How the cubic curve is. Okay, it is in the first and third quadrant, because if x is positive, x cube is positive. If x is negative, x cube will be negative. Okay, this is a curve which is something of this kind. Approximately, I am sketching freehand draw. It's approximately of this kind. It is approximately of this kind. Clear? Now look into the graph itself and analyze what is happening at the origin. Okay. Look into the graph itself and analyze what is happening. Okay. Look into the graph itself and analyze what is happening at the origin. What is happening at the origin? Okay, at x equal to 0. क्या हो रहा है x equal to 0 पे? Okay. What is happening at the x equal to 0? Okay. This point x equal to 0, this point x equal to 0 is definitely a stationary point. Sir, why it is a stationary point? Because at this point also when you draw the tangent, the first derivative is 0. And first derivative equal to 0 means stationary point. Okay. Right. But does it have a maxima? A maxima means this should be the largest value, then the function should decrease. Okay, it's not maxima. Is it the minima? If this was minima, this should be the lowest value. Matlab graph should be something of this kind. Now ye minima. It is some intermediate value only, neither minima nor maxima. So this is point of inflection. This is point of inflection. Neither maxima nor minima. Neither maxima nor minima. It is the option number D. It is the option number D. Okay. Good morning, Mr. Perfect. Now, for every given function, you cannot always recall and draw the graph. Na? For cubic or right, to theek hai. So can I apply it? Can I fit the previous method? Ye dekhte hain. Can I fit the previous method? Okay. So what is fx? X cube. Okay. So what is f dash x? 3x square. Stationary points means f dash x equal to 0. Stationary points means f dash x equal to 0. So what are the stationary points? Even the result will be by calculation also. Okay. 3x square is 0. X square is 0. Since it is x square quadratic equation, you should have the two roots. Okay, you should have the two roots. So what are the two roots? 0, 0 aa gaya. What are the two roots? You will get it to be 0, 0. Clear? The two roots you will obtain to be 0, 0. Dhyan dena. Okay. So these are the two roots. That is 0, 0. Okay. Now repeated hai. So now after the roots, as I told you, next step is what? Immediately you will go to the wavy curve. Immediately and again you will go to what? You will go to the wavy curve. Ye lijiye, I am drawing the wavy curve for you. Okay. And there is only one root. I will draw the value of that root. That is 0. Okay. And please mind that it is a repeated root. Please mind that it is a repeated root. At 0, okay, two stationary points are there. Okay. Good afternoon, Anna Sahib. Now the wavy curve, same method. It will always start from the right of the largest root. It will always start, yahi largest root hai, and it should start with the plus sign. It should start with the plus sign. And at every non-repeated root, it should change sign. So suppose, Okay, suppose what happens, as I told you one simple statement, at every root it should change the sign. Okay, let's fix with that. At every root it will change the sign. At every root it will change the sign. But here how many roots are available, dear? Here how many roots are available? Two roots at the same location, so it should change sign twice. ऐसा समझ लीजिए ना, two roots at the same location, it should change the sign twice. दो बारी sign change करेंगे. So if you change the sign two times, okay, plus remains plus. Plus 2 minus, minus 2 plus at the same instant, plus 2 minus, minus 2 plus, so ultimately it's a plus. Okay, now actually देखा जाए तो at this point first derivative is not changing in sign. Okay, this is the wavy curve for the first derivative is not changing sign. That is why it is POI. That is why it is POI. So even the wavy curve can identify POI as well. Okay, if there is a repeated root, double sign change, so plus remains plus, or if it was minus, it will remain minus. Okay, ठीक है जी, ठीक है जी, ठीक है, डन है. Okay, hope you are clear with the complete wavy curve. Okay, previous question में Hari, what you are asking is, previous question में, where is that wavy curve? You are asking that the local maxima is equal to the global maxima. Yeah, since I have only one, na? Yeah, since you have only one local maxima, देखो why it will happen. You are starting with the decreasing zone. Okay, then you increase. Okay, minima आया. Okay, then you go to the local maxima. Okay, then you again, okay, go to a local minima and then increase. No, not necessary, Hari. Not necessary. Okay, not necessary. Why? Because it depends what range you are talking about. Okay, suppose the function, so this is increasing. Okay, it can keep increase and go to the top. It depends on what interval is being asked, and we will come to that global maxima problem also. It depends. Okay, it depends on the interval given. Suppose if the interval is only this much. Okay, Hari. Okay, if the interval is this much, then definitely it is the largest, local also and global also. But if the interval is up to this point, if the interval is up to this point, then this particular point is the global, na? This particular point is the global, correct? Okay, so that's what. So we can't generalize it. ठीक है? अच्छा. Okay, now because we raised this question, let us go to the global maxima only. Let us see where is that global maxima question. Let's go to that only. अरे ये कहाँ पे आ गए? Let's go to that global maxima question only for a moment. Okay, acha. By chance global maxima question only is coming. Okay, by default next question is global maxima only, number 14. Here it is. Okay, find the minimum value of the function in the interval minus 3, 3. So whenever I tell you minimum value of a function in a particular interval, so I want the absolute minimum, the lowest value, global minimum. Okay, global minimum. Okay, in a particular interval if you want to find, it should be the global minimum actually. It should be the global minimum. It should be what? It should be the global minimum actually. ठीक है? So I will tell you the shortcut here. पहले shortcut बताता हूँ मैं. I will just tell you the shortcut here. What is that shortcut? Let's do it up. Anybody? Can you tell the answer? Can you tell the answer quickly? Just a moment. है ना? Solve it up. If you know the method, please tell me the answer. Oh, sorry, the voice was, I think, it left on mute. I went on, so it was on mute. Okay, now it should be okay. Don't worry, now it should be okay. Okay, even it should be okay. I just went on for a basic snacking. I was like little bit hungry and I thought we have to go till 21 questions, so let me regain some energy. चलिए आते हैं. Okay, cool, है ना? So you know, these are like 2 marker expected question for gate. Let me tell you, ठीक है? 2 marker straight, and the shortcut is first shortcut and then थोड़ा सा concept समझ लेंगे इसका. So what is the minimum value of this function? Okay, सबसे पहले what are the stationary points? What are the stationary points? F dash x, okay, equal to 0. That is 3 of x square minus of 6x minus of 24 equal to 0. That is x square minus 2x minus 8 equal to 0. That means x minus 4 x plus 2 factorize हो गया, x minus 2 x plus 4 equal to 0, and x is equal to the minus 2 and the plus 4. X is equal to the minus 2 and plus 4. Okay, ये क्या है? ये मेरे stationary points है. Now no need to classify which is maxima, which is minima. No need to classify that. Okay, no need to classify that. Okay, let's do something else. Okay, let's do something else. And what is that something else? What is that something else? Okay, let's do the calculation. The interval is minus 3 comma 3. Acha, this 4 na, it is outside the interval. Okay, your stationary points are minus 2 and 4, but 4 is outside the interval. ये भी ध्यान रखना है. Okay, this is outside minus 3 comma 3. So now the basic calculation. Basic calculation में क्या क्या करना है? Start with the end points f minus 3. Okay, then take the stationary points and then go to the end points. Calculate the value of the function at the end point and calculate the value of the function at stationary point, but only those stationary points which is inside, because the function is asking anything within, whether minimum, maximum, but within this interval. So if a stationary point is outside, I don't care about it. I absolutely don't care about it. Okay, बिल्कुल सही अनंता. Point put करके check करना है. तो ठीक है. What is f minus 3? Okay, f minus 3. So minus 3 का cube, that will be minus 27. Minus 3, okay, into 9. Okay, minus of 24x. Okay, so minus 24x will become plus 72, and then last में है plus 100. Okay, what will be f3? It will be 27 minus 3 into 9 x cube minus 24x, that is minus 72, and plus 100, and this will be minus 2 ka cube minus 8 minus 3x square, that will be 4, minus 24x, so that will become plus 48 and plus 100. Okay, let us write down these values that are being obtained. Okay, this is minus 27 minus 1 minus 54 and plus 72, it should be 18, so 118. Okay, next आ गया. Okay, minus 8 minus 12. Okay, minus 20. Okay, so you're 28, 128, and third one is 27 minus 27 cancel, 100 minus 72, this is 28. Tell me now which is the minimum, which is the maximum. क्या options है मेरे पास? Okay, out of the complete, whatever is the minima, maxima, global minima, global maxima, okay, it is out of these only. It is outside this, it is out of these only. So this will represent what? This will represent the global minimum, or also known as absolute minimum. Okay, global minimum. And this will represent, they can ask maxima also, or they can ask both also. This will represent the global maximum. This will represent what? The global maximum. This is the direct shortcut. Okay, so answer for global minimum as of now is option number B, that is the 28. Option number B, that is the 28. ये कर देना है आपको, ठीक है? That is option number B, that is known as the 28. That is known as the 28. ठीक है? Done है? Simple. Okay, simple. Now the logic is actually ना, when you check this stationary point, okay, देखो अगर wavy curve पे जाते हम, okay, suppose by chance you are going to the wavy curve. Okay, so the stationary points are minus 2 and 4. Minus 2 and 4. Okay, this is 4. So यहाँ plus होगा, then this will be minus, and then this will be plus. Okay, so what is the nature of the function? Okay, what is the, yes, you can use wavy curve, but it's not required. Understand that. Okay, understand that. Okay, so understand G1 everything. So ultimately you should remember the shortcut, but still if you want to understand, please have a look into this. So what is the nature of the function? It is initially increasing. the nature of the function, it is initially increasing. Okay, then it reaches a maxima and then it is decreasing. Minus means decreasing. It decreases to some value and then after that it will increase. This is roughly the nature of the function. This is roughly the nature of the function. Okay, this is what is the rough nature of the function. Okay, this is what is the rough nature of the function. Okay, now this is the local maxima, this is the local minima. Okay, now is the local minima equal to the global minima? Sometimes yes, na Jeevan. Why we are taking -2? Because understand like this. Okay, if the range of the function starts only from this point, okay, if the range of the function starts from only this point, okay, and suppose it goes up to this point, suppose it goes up to this point, isko hata dete. Suppose it goes up to this point. So please remember that this point is the local minima, no doubt. This is the local minima, no doubt, but it is also the global minima. It is also the global minima. Okay, what is the starting point? It can be anything. Suppose you are starting from x equal to a and you go up to the x equal to b. Okay, so sometime local minima will be global minima. Okay, acha. What about this particular point? Okay, what about this particular point? Isko dekhoge. This is the local maxima. No doubt it is a local maxima. But is it the global maxima? Is it the largest value of the function in the interval a comma b? No. Okay, so after a certain point, okay, the value is increasing because finally the nature of the function is increasing. It will keep increasing. If I give you larger and larger range, it will be more and more increasing value. That means if it is given up to this point, this will be the global maxima. Clear, everybody? This will be the global maxima. Okay, this will be the global maxima. So that is why now it depends what is the range given. I cannot tell initially. I am not sure. So what I am doing is, let us calculate the value of the function at the endpoints, both the endpoints. Okay, because again I say, suppose the a was starting from here. Suppose the a was starting from here. Then this is only local minima but not the global minima. What will be the global minima? This will become the global minima. Are you getting it? Suppose the a point is given here because initially it is a decreasing range. If you go to left side, you will go to the negative smaller values. Okay, so if this is the initial point, this is only local minima, but this will be the global minima. Clear? So what is the candidate of global minima? What is the candidate of global minima? It is either the end point or the local minima. What is the candidate for global maxima? It may be local maxima. Suppose the end point was given up to this. Agar ye b hota. Suppose if this was the value of b, then what will you do? Okay, then what will you do? Then this is the local and this is also the global. This is the highest value. Okay, so where can be global maxima? It can be either at the local point or the end point. Okay. So in short, what I can tell you is, please remember one point. Okay, in short, what I can tell you is, global maxima or minima can be obtained where? Okay, at local maxima, minima respectively, or at the end points, okay, of the given interval a comma b. At the end points of the given interval a comma b. Okay, that means, that is why you have to check both. So अब क्या कर रहे? Finally, what was my method? I am not involving in the graph to solve the question. I am not involving in graph. Concept comes from graph only, but I am not involving in graph. I calculated the stationary point, that's it. I don't know which is local minima, which is local maxima. अरे क्यों निकालना है? Forget ना. Which of them is local minima, local maxima? That is obtained by wavy curve. Why? Forget it. Only calculate stationary point and straightforward calculation. The value of the function at end point and the value of the function at the stationary points. Only one thing is, I skipped this stationary point because it is outside the interval. It is outside the interval, but ये ध्यान रखना. ठीक है? Okay. ठीक है. So ये भी मैं लिख देता हूँ यहाँ पे. Which local minima, local maxima to take? Okay, which is within a comma b. Which is within the a comma b. Clear है? बिल्कुल सही है. Okay, this is the actual concept and this is the direct shortcut. You have to apply this, and these are 2 marker gate questions. These are 2 marker gate questions. Let's go to the next one quickly. Question number 15. Okay. Question number 15. If e power y is x power 1 by x, then y has what? If e power y is equal to x power 1 by x, then y has a maxima at what? So it's a non-polynomial case now. Wavy curves are only for polynomials. Okay, remember. Okay, so we have to solve it by the regular differentiation method. Okay. Then y has a maxima or minima, and at what point? Okay, so what is y actually? E power y is x ki power 1 by x. Now, the y kya hoga? First, to differentiate dy by dx, let's be very clearly writing y. So y will become ln x ki power 1 by x. Okay, power inside the log, outside multiplied kar denge, so 1 by x log x. So actually y is nothing but log x by x. Differentiation rule of division rule of differentiation you can use, and let us write down dy by dx, that is the first derivative, denominator square hoga, denominator x constant, differentiation of numerator log x is 1 by x, minus log x constant, differentiation of x is equal to 1. So this is simply turning out to be 1 minus log x divided by x square. Okay, now you have to solve what? You have to solve dy by dx equal to 0. As always, dy by dx agar 0 kiya, so that means 1 minus log x, numerator is 0, and that is possible at x equal to e. Log e is 1, 1 minus 1 will be 0. So x equal to e. The stationary point is definitely x equal to e. Ye to nahi hai. But whether it is maxima or minima at that point, whether it is maxima or minima at that point. Okay, second derivative. No wavy curve here. Wavy curve is only for polynomials. Okay, don't do the mistake of wavy curve here. Okay, so now second derivative, d2y by dx square. We'll go to the second derivative test then. So what is d2y by dx square? Differentiate this function again. Okay, so again, denominator ka further square, so x square ka square, x power 4, then x square constant, differentiation of 1 minus log x will be minus 1 by x, minus of 1 minus log x constant into differentiation of x square will be 2x. Okay, now what is the value of d2y by dx square? If I simplify this, this is minus x, x square, x cancelled. Okay, minus of 1 minus log x minus twice 1 minus log x into x. Let me write it clearly, minus 2x into 1 minus log x whole divided by x ki power 4. But what should be the value of d2y by dx square at the stationary point? You are concerned about stationary point only, na? So at x equal to e, okay, it will become, ek pehli baat to x cancel ho jayega, one of the x will get cancelled, so minus 1 minus twice 1 minus log x divided by x cube, one of the x cancelled. Okay, so this is minus 1 minus twice 1 minus log e, put down the value e, divided by e cube. Log e is 1, so 1 minus 1 cancel. Okay, so minus 1 upon e cube. E to positive hota hai, so minus 1 upon e cube, because of the minus is negative, and second derivative negative, confirming what? Confirming local maximum. Okay, so it has a maxima at x equal to e. It has a maxima at x equal to e. Correct? You can post it in the Telegram, Rajiv. Correct hai? Correct. So Sagnika, Risit Ghosh, Ananta, Venkatram. Okay, correct answer, dear. Okay, it's option number A, maximum at x equal to e. Acha, it is the local maximum. Can I say it is the final maximum also? The option doesn't say local maximum. They are only saying maximum. देखो, logic ये बोलता है, if there is only one stationary point, there is only one stationary point, there is no more stationary point, and that stationary point is a local maxima. Okay, there is no more stationary point. देखो, इसको ऐसा देखना. There is only one stationary point, and that is local maxima, and there is no more stationary point. Since there is no more stationary point, there cannot be any more decreasing value. Okay, agar koi decreasing value hota, if there was any local minima, then there is a chance that function can have more higher value. Local maxima may not be global maxima. Okay, but there is only one stationary point, and that too only local maxima. So that local maxima is also a global maxima. ठीक है, clear? That is also global maxima. Okay. Clear? So there is one stationary point. So if that is local maxima, it will also be global maxima, or if it is local minima, it will also be the global minima. Like this particular point, okay, like this particular point, this is local maxima, and at the same time it is the global maxima also. It is both here. It is the both. So if there is only one stationary point of a function, then that stationary point will also be local and global. मतलब maxima है तो local global maxima, local minima तो global minima. That's what it is. ठीक है? So now quickly, next one dear, 16th question. For a right angle triangle, if the sum of the lengths of the hypotenuse and the side is kept constant, in order to have maximum area of the triangle, the angle between hypotenuse and the side. So some maxima minima question. I will share the telegram link, Rajiv. Just wait. Some maxima minima question. Okay, based on the word problem, some geometrical application. Okay, so for a right angle triangle, let's bring the right angle triangle into the picture first of all. Okay, so for a right angle triangle, क्या बोला है? If the sum of the lengths of hypotenuse and the side is kept constant, okay, this is the hypotenuse. Suppose that is h, and suppose this is the side. Okay, suppose that is s. Sum of them is kept constant. Okay, in order to have maximum area of the triangle, what is the angle between the hypotenuse and the side? What is the angle between the hypotenuse and the side? The question is this theta. Okay, what is to be taken constant? Okay, if the sum of the lengths of hypotenuse and the side is kept constant, suppose it is c, it is constant, it is c. Okay, in order to have maximum area, acha, what is the area of the triangle? Half into base into height. Acha, so what should be this side equal to then? This can be written as, by the Pythagoras theorem, under root of h square minus s square. Okay, so the area will become half into base. Base is equal to the side. Okay, multiplied by what? Multiplied by square root of, okay, ye h se confuse mat hona, that is the hypotenuse, half base height. Okay, so that is h square minus s square. Okay. So now we can substitute h in terms of s, na? So what is that area then? Okay. Let us say the area is a, and that is half into the side s into the under root of h square minus h square, under root of h. What will be h? H will be c minus s. C minus s whole square minus s square. So isko solve karenge. So that will be half s root over of c square minus 2cs a square minus 2ab minus b square, sorry, plus b square. So plus s square minus s square ko hata dete, that is just 0. Okay, so c square minus 2cs, where c is constant. Okay, where c is constant. Okay, le cos theta ke form mein bhi le sakte hai, your call. Okay, you can take it in the form of cos theta also, that's also okay. Okay, that's also okay. Now let's come here. Okay, so now this is just like y as a function of x, half x under root of c square minus 2cx. Just like y as a function of x, here you have the area which is the function of the side. Okay, now you want the maximum area, so you will start with dy by dx. Okay, we are looking for y max, na? Looking for y max, so we'll start with dy by dx. Okay, let's solve in terms of x and y. You are more comfortable, I think. Okay, so dy by dx, half को separate करते हुए, product rule, x constant, differentiation of root term is 1 by 2 root x, 1 by 2 root x, but this is differentiation with x. So by the chain rule, if you differentiate, you will get minus 2c again, plus the c square minus 2c as constant, differentiation of x will be 1. Okay, and you have to equate it equal to 0. Okay, we have to equate this equal to 0. तो चलो इसको solve करते हैं अब. Okay, so I should be getting the dy by dx here, 2 cancel करते हुए half. Okay, what is this? This is minus xc. Okay, plus shift this on the other side, 2 cancel हो चुका है. Root and root a will be a, so you will get c square minus 2cs whole divided by this term. Root c square minus 2cs equal to 0. Now if you are going to equate this to 0, तो how much is this? अरे ये s नहीं है, मैंने कहीं पे s लिख दिया क्या? Sorry, minus 2cx. Okay, that is 2cx. Okay, everywhere I am writing in terms of x first of all. ठीक है, so कितना हो गया dear? Actually if you equate to 0, you will get c square numerator minus 3cx equal to 0. Okay, तो c minus 3x equal to 0. Okay, so what should be the value for the c? Cannot be 0. Okay, so c will be equal to 3x and hence x is equal to c by 3. We have got the value of x. Okay, we have got the value of x. Dear, what is the value of x is c by 3. h plus, अच्छा ये जो x है ना, ये x was equal to the side, that is c by 3. Okay, so h plus s, okay, that was c. So what is hypotenuse then? Okay, that will become 2c by 3. Okay, what is the value of cos theta then? Theta भी निकल जाएगा. What is the theta in order to have maximum area? So let's find the cos theta, because cos theta is base upon hypotenuse. Cos theta is base upon hypotenuse. So what is the base? C by 3. Hypotenuse 2c by 3. C is not required. C by 3 cancel. It is half. Cos theta equal to half at theta equal to how much? Cos theta is half at theta equal to 60 degree. Cos theta equal to half at the theta equal to 60 degree. At the theta equal to 60 degree. So the answer is option number C. Correct answer is option number C. It's a geometrical application question, you can say. ठीक है? चलो done है. All right. So if you are still motivated after 2 hours of the session, do not forget to put your attendance. That means do not forget to hit the like button. Do not forget to hit the like button, and let's come to the next question. Then number 17. Okay, for a function, okay, the optimal value. Optimal means again maxima or minima, extreme, optimum. Okay, now 2 variable function. It's a 2 variable function now. What is the method to determine maxima or minima for 2 variable function? Okay, maxima or minima for 2 variable function. First, okay, you will find the stationary point. Okay, the method is, as always, number 1, you will focus on stationary points. A quick review, guys, quickly. Number 1, stationary points. Okay, to solve the stationary points, okay, we will take the P and Q. P and Q are, designated as the first derivatives. Yes, correct. PQRST method. Correct, Kosh. Okay, correct, Ananta. So now, what is a stationary point? The first derivative. How many first derivatives? 2 first derivatives, because it is a function of x and y. Okay, and because it is a multivariable function, we will take the partial derivative. Okay, del f by del x. What is P? Call the P as del f by del x, or you also call it as fx. Fx, this is the notation. Okay, then take Q. Q is del f by del y, or that is also fy. Okay, equal to 0. Take the first derivatives equal to 0. Okay, now let's keep doing it. Okay, let's keep doing it. Okay, then I will tell you the step number 2. Okay, let's keep doing it for the function parallelly. Okay, so what is f? What is f? 4x square plus 6y square. 4x square plus 6y square minus of 8x minus 4y plus of 8, correct? Yeah, this is the f. So what is the value for P? P means del f by del x. Okay, del f by del x, and that is equal to 4 to the 8x, then minus 8, and put it equal to 0. You straight away get x equal to 1. Okay, Q also equal to 0. That is del f by del y, partial derivative with y, that will be 12y. See, what is the rule? When you are partially differentiating with y, x will be constant. If you are differentiating with x, y will be constant. Okay, so you will get 12y, then minus 4. Okay, equal to 0. So y is clearly 4 by 12, that is 1 by 3. So you have got some value of x and y, no? Okay, so similarly, you calculate the stationary point. Okay, and let the stationary point be There can be more than one stationary points also, but suppose the stationary point is suppose x naught comma y naught. Okay. Now next step. Okay. Acha. Before I go to the next step, let me tell you one thing here. Okay. For all those who have been watching the session, it's almost around 2 hours now, and there are 3-4 more questions to go to learn more concepts. But you have been continuous, you have kept the patience. As you know, all my PDFs were password protected. You will get the complete PDF. Every question, every formula, every solution, every concept that I'm writing, you will get it up in my Telegram group. But the rule is, as always, the PDFs are password protected from my end, and the password for today's PDF randomly created always. Okay, and the password is local, LOCAL, everything in small, LOCAL. Acha, where will you get the PDF? In case you are not connected in Telegram, I shall share you the Telegram link, and then we will continue our discussions. Just a moment. Here is the link of the Telegram. You will get the PDF in the Telegram group with the password mentioned. Okay, chalte hain. Okay, yeah. So the next step now. The next step is calculate the value of RST. Calculate, actually not RST, calculate RT minus S square at the stationary point, whatever stationary point you obtain. Calculate RT minus S square at the stationary point. Now what is RT minus S square? Right, what is R, what is S, what is T? So PQ, R, S, T. Okay, now we'll come to the double derivatives. Del 2f by del x square will be the R. This is also known as fxx. Fxx means double differentiation with x. Okay, S. Okay, then let me write down S. S is known as del 2f by del x del y. That is the differentiation with x and y. Once with x, once with y. We also call it as fxy. Okay. And then T, double differentiation with y only. Del 2f by del y square. This can be represented as fyy. Okay. Calculate the RT minus S square at the stationary point. Now, what is the results? Okay. What is the results? Okay. Now, you have to check. RT minus S square. Okay, the RT minus S square may be positive, okay, or maybe less than equal to 0, negative or 0. If RT minus S square is negative, that is less than or equal to 0, then that point for two variable function will represent neither maxima nor minima, and that point will be referred to as a saddle point. Okay, but if RT minus S square is positive, so you have to go ahead and check the value of R. Okay, now you have to check the value of R individually. Okay, at the R individually. If R is positive, that will represent the point of local minima. If R is negative, it will represent the point of local maxima. This is the conclusion, and all the calculations here to be done, all the second derivative calculations to be done at the stationary point. Okay, so now let's complete this for the particular question. We obtained till P and Q. Okay, so now P. Now what is R first of all? R. Okay, that is del 2f by del x square, double differentiation with x. So already you have the first derivative with x, 8x minus 8. Again you differentiate, you get 8. Okay, then S, del 2f by del x del y. Once differentiation with x, once with y. So already you have differentiated this function with x. Okay, now differentiate with y. So 8x minus y. Okay, with respect to y, it is purely constant. It is purely constant, so answer will be 0, because when you differentiate with y partially, again I am telling x will be constant. Okay, or you can do reverse also. You have differentiated once with y, now differentiate this function with x, but it is independent of x, constant hai to 0 aayega. Okay, T. Okay, what is T? As I mentioned, del 2f by del y square, double differentiation with y. This is the first derivative, again differentiate with y, you are getting 12. Again differentiate with y, you are getting what? You are getting the 12. Done hai? You are getting the 12. Okay, so now calculate RT minus S square. Okay, at the stationary point, what is the stationary point? 1 and 1 by 3. 1 and 1 by 3. What is the RT minus S square? Actually, RT minus S square in general is positive here. In general is constant here. Okay, RT minus S square, that is 96 and positive. Whenever RT minus S square is positive, okay, you should check the value of R. What is R? R is equal to 8. R is equal to 8, positive. R positive means local minima. So the stationary point 1 comma 1 by 3 is the local minima. Okay, the stationary point is 1 comma 1 by 3. Okay, so what you have obtained, dear, the function has a local minima. Okay, at the point 1 comma 1 by 3. Acha, only one stationary point. Again put that concept, only one stationary point. So if that is a local minima, it is also global minima. Single stationary point case. Okay, so I'll just call it as minima. So there is minima at 1 comma 1 by 3. Now function is asking, okay, function is asking the maximum to niklega nahi, yahan pe minimum hi niklega. So what is that minimum value? What is that minimum value? So put down the value 1 comma 1 by 3. It is 4 into 1 square plus 6 into 1 by 3 ka square minus 8x, 8 into 1 minus 4 into 1 by 3 plus of 8. Okay, let's just try to solve this expression. 4 plus 6 by 9, that will be 2 by 3 minus 8 minus 4 by 3 plus 8. 8 to 8 cancel. Okay, this is 2 by 3 actually. The 2 by 3 minus 4 by 3 will be minus 2 by 3. So 4 minus 2 by 3. So it should be 10 by 3. It will turn out to be 10 by 3. And 10 by 3 representing the minimum value. Option number A, dear. Option number A. Check out everybody. Correct. Yes, Ghosh. Okay, option number A is the very correct answer. So, two variable maxima minima, not very frequent. Single variable maxima minima is very important for GATE. Two variable, sometimes they can ask, so not very important, but you must know. Sometimes you never know that, sometimes is GATE 2024 or what. Okay? Next question, number 18, quicker. Okay, quickly now. So if u is a function of r, where x is r cos theta, y is r sin theta, the polar coordinates actually, then what is uxx plus uyy? Partial derivative basic question actually. Partial derivative basic question. What is uxx plus uyy? Dekho, u is a function of r. Okay, so what is ux? Ux means del u by del x, first derivative. Okay, so once you differentiate function f, you should get f dash r, but you are differentiating not with r, you are actually differentiating with x. So chain rule, and chain rule will ask you to use del r by del x. Now, what is del r by del x? What is del r by del x? X is equal to r cos theta, y is equal to r square theta. Okay, so what is x square plus y square? That will be r square, na? Because cos square theta plus sin square theta to 1 hua. Okay, so from here you can tell what is r. Root over x square plus y square. So dear, what is del r by del x? Tell me what is del r by del x? What is del r by del x? Differentiate the root term, you get 1 by 2 root x. So 1 by 2 root x square plus y square. By the chain rule, you again differentiate x square plus y square, you will get only 2x because you are partially differentiating with x. So y is like a constant. Okay, so 2 से 2 cancel किया, this is equal to x divided by, अच्छा, again root over x square plus y square, directly you can write it as r, x by r. Okay, so dear, I can now say that, इसको separate रखते हैं. Now I can say that this is equal to f dash r is whole multiplied by x by r. That is the first derivative ux. अच्छा. Okay, these are always symmetry based question. Whatever you differentiate with x, you get the result. Similarly, not same, but similarly you can apply for y also. So इसलिए if you complete with x, I think you are done with most of the part. Now what is uxx? Okay, that is del 2u by del x square. I told you, double differentiation with x, partial double differentiation with x. Okay, so partial double differentiation with x. So कितना होगा? Now you know f dash r into x by r. So suppose f dash r constant, differentiate x by r. तो x by r chain numerator by denominator form, ये हो गया r square. R x1 क्योंकि du by dx है minus x constant differentiation of r will be del r by del x plus now next time पे x by r constant take f dash r तो f double dash r the differentiation of f dash will be f double dash but again by chain rule del r by del x because you are differentiating with x so f dash का derivative f double dash but del r by del x by r constant. So product rule I have applied. Let's try to simplify this trend. So what is uxx? F dash r. This is equal to the f dash r, and then you have r minus x into del r by del x. What is the value of del r by del x? Put down the value again. That is x by r whole divided by the r square. Okay, plus x by r, okay, plus x by r, okay, plus x by r, f double dash r, okay, x by r, f double dash r into del r by del x. Del r by del x again x by r आ जाएगा. Okay, so let's try to simplify whatever is turning out to be. This is f dash r, okay, you multiply here r square minus x square by r cube plus x square again by r square f double dash r. Okay, now similarly the uyy will come. Okay, no need to solve it separately. Similarly uyy will be f dash r, difference will be r square minus y square upon r cube plus y square by r square f double dash r. But with respect to x and y, r is like an identical function. Huh? Okay, when you are differentiating with x, y is constant. It is like constant plus x square. But if you are differentiating with y, x will be constant. So constant plus y square, isn't it same function? Constant plus square. So results will be same only. No need to repeat it. Obviously results will be same. Now you just add both. Okay, the question is asking uxx plus uyy. Okay, so when you are going to add both, f dash r को common लेते हुए चलते हैं, so you will get the f dash r and then r square plus r square will be 2r square, okay, minus x square minus y square, तो minus of x square plus y square whole divided by r cube. ये तो हो गया first term. Okay, now let's come to the second term. Okay, f dash r अब f double dash r upon r square common लिया यहाँ पे. Okay, f double dash r divide by r square common and then you add x square plus y square. Okay, then you are going to get x square plus y square, but again x square plus y square is equal to the r square. So ये हो गया f dash r 2r square minus r square divided by r cube plus f double dash r x square plus y square r square. Okay, और यहाँ पे r square तो r square cancel. Your final answer uxx plus uyy is equal to r square upon r cube तो 1 by r आ जाएगा, तो f dash r upon r plus f double dash r, f dash r by r plus f double dash r. Okay, f dash r plus r, f dash r by r plus f double dash r. Okay, so f double dash f dash r by r, option number A itself. It is the option number A. It is known as the option number A. Okay. Done hai ji. Yeah, it's a good question. Okay. Now such partial differential question, if it involves this calculation, so it can be 2 marker. Some partial derivative question in exam can be simple 1 marker, but this can be definitely 2 marker. Okay. And you have to employ the symmetry of the problem also to save your time. Next question, dear. Here it is, number 19. Okay, a Jacobian based question. Okay, not direct question ज़्यादा नहीं आता है, but you must know what is this? The Jacobian. Okay, del uy upon del xy is given by, is solvable by a determinant where you take first u and v. U and v are 2 functions of x and y. Okay, u and v are 2 functions of x and y. Okay. Okay, so del u first differentiate. First row में क्या आएगा? The differentiation of u with x and with y. तो del u by del x, del u by del y. Okay, then v. Second row में you will take v. Okay, v with x, v with y. Del v by del x, del v by del y. This is what will come up here. ठीक है? This is what will come up here. Okay, so you have to just put down these values. So for this particular question, what the answer will be? Okay, shall I write it here only? Del u by del x, differentiating with x का derivative 1 upon x square का minus 1 by x square, so 1 minus y square by x square. Differentiating u with y, okay, so x will be constant, y square का differentiation 2y by x. Del v by del x, differentiating v with x, 1 upon x का differentiation minus 1 by x square. Okay, now del v by del y, differentiating with y, okay, so 2v by x again, okay. Okay, now just cross multiply it to get the answer, a determinant. Okay, that will be 2y by x, okay, minus 2y square y cube upon x square x cube. Okay, next cross multiply minus, okay, again 2y square y cube upon x square x cube. Okay, ये दोनों हुआ cancel and the answer is simply 2y by x. Answer is simply known as the 2y by x. Option number B. Answer is 2y by x. Answer is known as the 2y by x. 2y by x. Done. 2y by x. Done. Next question. Okay, number 20. If u is equal to x cube plus xz square plus y cube plus 3xyz, where x is e power t, y is cos t, z is t cube, then what is du by dt at t equal to 0? Okay, now there is one option. You substitute everything in terms of t, or the second option, apply total differentiation. Okay, what is method number 1? Okay, substitute xyz. That is also possible. Okay, substitute xyz. Okay, in terms of t. Okay, or method number 2, you can apply total differentiation. Now, the intent of this question I have taken so that you also revise total differentiation. Okay, so if u, okay, if u has been given to you, okay, which is a function of 3 variable x, y, z, we write down the total differentiation, okay, of u du as del u by del x into dx, del u by del y into dy, del u by del z into dz. This is the total differentiation rule, you must know. Okay, total differentiation rule. Okay, so this is what, okay, you must be knowing. This is the total differentiation. Okay, so now you want to calculate du by dt. Simple, na? You want to calculate du by dt. So let's copy the function. What is the function? Okay, x cube plus xz square plus, लिख लेते हैं एक बार इस function को once again. Okay, u is equal to x cube plus xz square, x cube plus xz square plus y cube plus xyz plus y cube plus xyz. Okay, and you want to calculate du by dt actually. Du by dt. So all the terms will be du dt. It is actually chain rule only, Ananta. ये भी chain rule से ही आया है. This is nothing but the chain rule expansion. Okay, del u by del x into dx by dt. Okay, del u by del y, chain rule से dy by dt, del u by del z into dz by dt. Okay, where x is e power t, ये भी लिख देता हूँ वापस से, x is e power t, y is equal to the cos t. Okay, and z is equal to, okay, t cube. Okay, so let's put down du by dt, del u by del x, differentiation with x, partial differentiation with x, 3x square plus z square plus yz, dx by dt, e power t differentiation, e power t, del u by del y, differentiation with y, okay, xz constant, so 3y square plus xz into dx by dt, cos t ka differentiation sin t, dy by dt tha, sorry, plus del u by del z, differentiation with z, so this is the term 2xz, and यहाँ से आ जाएगा xy. Okay, dz by dt will be 3t square. Okay, at what value I want? I want at the t equal to 0. Okay, at t equal to 0. what is du by dt? What is du by dt? ठीक है, बताइए what is the du by dt? चलो, so अगर t का वैल्यू 0 है तो what is x? अगर t इक्वल टू 0 है तो e पावर 0 1, cos 0 is 1, 0 cube is 0. ओके, तो x y z करस्पॉन्डिंगली 1 1 0 रखते जाएंगे. ओके, सो 3 into 1, z का वैल्यू 0, z का वैल्यू 0, e पावर 0. ओके, नेक्स्ट इज 3 into 1, x जहां z जहां पे भी आएगा 0, माइनस साइन 0, दैट इज 0. ओके, प्लस 0, x into y 1 into 1 into 3 into t 0. Okay, so the only answer that is coming is this part is totally multiplied by 0, third is 0, only you are getting the first part, 3 into e power 0, answer should be 3. Check out the answer dear, it should be 3. It should be the 3. It should be the 3. Option number A. Option number A. Ashok and Venkat say B, minus 3. Is there any minus involvement? Did I miss something? T equal to 0. No. Cos t, cos 0 is 1. Cos t था ना y? हाँ, cos t t cube. No, it is a guys. It is a Ghosh. So Ashok and Venkat, please you can check it up. It should be a, not minus 3. It is plus 3 only. ठीक है? चलो, the last question for the day 21. Okay, the last question for the day, that is the 21st. Here it is. If u is tan inverse x cube y cube upon x power 4 y power 4, then what is x del u by del x plus y del u by del y? x del u by del x plus y del u by del y. ठीक है, देखो यहाँ पे if you shift the tan inverse on the left side, first of all, suppose that function is equal to v. Let v, which is equal to tan of u, is given by x cube y cube upon x power 4 plus y power 4. X power 4 plus y power 4. Okay, is it a homogeneous function? Now, what is a homogeneous function? A function, okay, in the form of ratio of polynomial, numerator by denominator, is homogeneous if numerator and denominator are both homogeneous individually. So this is a homogeneous function. See, this is power 6, this is power 4 and power 4, both are having the similar power. That is why the denominator is also homogeneous. So this is homogeneous. Okay, this is homogeneous function. Any more doubts with respect to homogeneous? आप पूछ लीजिए. I'm just giving you the homogeneous function orally. Okay, homogeneous function with what degree? With the degree of numerator 6, degree of denominator 4, so degree will be 2. Okay, degree will be 2. Okay, now point that you have to revise here is, okay, because V is homogeneous, okay, because V is homogeneous, yeah, in general, if Z is homogeneous, with degree n, okay, with degree n, then number 1, x del z by del x plus y del z by del y will be equal to nz. And number 2 result पे भी question आ सकता है. So I am telling you both, x square del 2z by del x square plus 2xy del 2z by del x del y plus y square del 2z by del y square is equal to n minus 1 into z. Both of them are known as the result of Euler's theorem. This is the Euler's theorem for homogeneous function. अब यहाँ पे कौन सा function homogeneous है? V. See, directly u is not homogeneous. Okay, directly u is not homogeneous. So what I can say is I have got a function v which is equal to tan u, and that is homogeneous. Okay, that is homogeneous with the degree 2. That is homogeneous with what? With the degree equal to the 2. With the degree equal to 2. Okay, so the first result, x del v by del x plus y del v by del y should be nv, and n2 should be 2v. It is in terms of v, but the question is in terms of u, because function भी u given है. Okay, so now let's substitute. So x del v by del x. Okay, v tan u का differentiation. Sec square u. By chain rule again you will write del u by del x. Okay, plus y. Again, tan square differentiation, tan theta differentiation, sec square theta. Okay, del u by del y is equal to 2v and v is equal to 10u. So now I have substituted in terms of u. Okay, so solving it, I am getting x del u by del x. यही तो question है. Plus y del u by del y. What is x del u by del x plus y del u by del y? It is equal to 2 tan u upon sec square u. Okay, तो denominator में tan sin by cos, one of the cos will get cancelled. Sec को ऊपर ले लो. So it should be 2 sin u and one more cos u. So the answer is sin 2u. The answer is sin 2u. Perfect answer, Ghosh, Ashok, Ananta. Correct. It's sin 2u. It is the sin 2u. Option number B. Sin 2u is the very correct answer, dear. Okay. Done hai? Chalo. That's it. So this was the 21st question of this complete differential calculus revision. Okay, so guys, if you want to enroll to the GATE crash course, okay, to have the complete syllabus coverage in the remaining time with the fast track theory revision and with detailed problem practice, okay, live classes, recorded lectures, study material, mock tests, practice quizzes, everything available. Okay, so you can contact 924-133-666 if you have any queries regarding to the batch. Okay, or else you can directly enroll in the BYJU'S exam prep app. Okay, it's available for all branches, ECEE, CS, mechanical, civil, everywhere. Okay, I've already given my Telegram link. Meanwhile, in the session you will get the today's PDF, but password protection ke saath. Okay, and I've told you the password few minutes back. Okay, yes, we'll plan vector calculus also. Like I have covered integral calculus, I have covered differential calculus. Next, definitely sometime I'll target the vector also. Don't worry. That's it from my side, guys. Bye bye. Thank you. Stay safe. Take care. It's at almost 2.5 hour session, but hope it is fruitful. Almost, I'll say almost everything. At least जितने important part है वो सभी आ गए. It's like almost complete review of the differential calculus because I've not only taken question with every question, some revision. Okay, some important concepts also we have discussed. Bye bye. Stay safe and take care of yourself.